Hello, and welcome everybody. Now that we're all done with the AP task, I'm sure you're all breathing a little freer. If you are not submitting to the AP board and you still haven't turned it in, please get it into me so that I can give you a grade. I will be pushing out all of my feedback to you later this week, so you'll see exactly how you did. Quick side note, I'm not obviously three AP graders, which is I think how many read your actual submission. So my opinion might slightly differ from the AP graders, but I doubt it'll differ a whole lot. So, we might disagree on a point or two, but overall you should get a pretty good gist of how well you did. Farther, I think this year they'll be especially lenient, so I wouldn't be surprised if overall the AP grades would be higher than what I would consider them to be. But we'll see. Who knows? Uh, Once again, I am still happy to take you on in your game of choice. If you come to one of our live meetings, they're pretty lonely if no one shows up. So please consider coming. And if you have any questions, of course, I will be happy to address those or go over any concepts from the class you would like. We are moving on. So last week we did objects. Today we are doing permanent data storage. So pretty exciting stuff. With this, you'll really have a whole lot of utility available to you in your programming. And you can do a lot of stuff with this. We've been talking about volatile data a lot, even though we didn't really call it that. That's pretty much any data you've used so far has been volatile. So we'll identify volatile and permanent data, and we'll use records to create apps with usability over multiple sessions. So let's see what this is all going to look like. Before we can really talk about what this whole permanent data storage thing is, let's talk about the volatility of data. So your computer has two levels of data storage, basically. The closer we get to the CPU, that's where all the actual magic happens. That's the only part of your computer where, well, unless you have a graphics card. I digress. In a simple computer, this is the only part of your computer that's actually doing calculation. So it's doing very simple things like adding and subtracting numbers, binary digits, and it's doing these operations really fast, and that's what's causing your computer to actually function. Well, we want to store a lot of those zeros and ones before the CPU can get to them so that we have them in easy access for it to reach. The closer you get to the CPU, the faster your data is able to be accessed. So if you have a program running in a computer, lots of parts from that program are stored really close to the CPU in various levels of cache and RAM and so on. And if you're not using a program, it's stored farther away on a hard disk. Now, the tricky thing is, all of these really fast versions of memory, cache, RAM, and so on, use electricity to keep your data actually alive. If you turn off the power supply to them, then the data is completely lost instantly. Therefore, obviously, this is not a very good solution if you want to have something available to you the next time you turn something on. And up until now, all of our programs have worked in this manner. If you ran the program once, it would keep track of all the variables, arrays, objects, whatever you had in there, and as soon as you closed it out, it was gone. There was no further access to that information. It was wiped out. Well, we are going to today talk about how we can kind of get a different way of storing information such that we can access it at a later date, and how do we actually do that. Here are some pictures if you've never taken apart a computer. It's kind of nice to look at. So this here is your CPU. This is where actually all the calculation takes place. It's kind of small, but yay large, maybe 1.5 inches by 1.5 inches or so. So it's pretty impressive that this little guy right here is really doing all the heavy lifting. This is a stick of RAM. You typically have a bunch of these inside your computer. This keeps track of all the current things you're doing and feeds them to the CPU for processing, and then takes them back and holds them for a bit. And then sometimes, if you're not using it anymore, it's going to write it to this guy right here. This is your hard drive, although many of you, I'm sure, have solid-state drives now. Solid-state drives work on a different principle, but the idea is still the same. This is a permanent data storage location. It's a little bit slower to access, but if I was to turn off the power, this guy would retain everything. It's a magnetic disk where everything is written to it. This graphic is a little bit beyond the scope of this class, but I think some of you might enjoy it. So the idea here is the closer you get to the actual processor, which has a couple of really fast memory storage locations on there, the more expensive and the more volatile your memory is. So all the way over here, and this is a little dated, these speeds are now a lot faster and larger. But if we get really close to our processor here, notice that the size gets really small, but the price per megabyte spikes. So this kind of memory is really expensive to manufacture. And as we get farther and farther away, this is our RAM over here, then you'll see that the price per megabyte will really quite substantially drop. And the speed does as well, and the size increases. So megabytes, remember, 1,000 times larger than kilobytes. So you have quite a bit more space here. And as you go down the line, the trend continues. So just an interesting aside about hardware, but let's get back to software here. So far we stored data in our programs in cache memory. Now we'd like to move it farther away. We'd like to store it in a hard drive so that we can get to it later. So we're going to be using a database. A database is simply a place for you to put whatever information you'd like, and then you can access it later. In AppLab, they've set up a method for doing so called a record. And a record is just the kind of objects that stores their information. So let's take a look at that real quick. There's some interesting stuff going on here. So first of all, this lesson has a good video to go along with it right in the first bubble here. I highly recommend you watch it. Now, permanent data storage is done through create a record. This is the command you give the programming language, and I'd really quickly like to kind of dissect this command because it's quite interesting. It has a lot of the stuff we've talked about before kind of all working together. So first of all, you need to give the ID of the table you'd like to store things in. A table is just your little database that you're using. Think of it like an Excel spreadsheet. If you've ever worked with one of those, it's simply an entry in your Excel sheet, and then the program can pull from it or write to it. The next thing is you send it an object. Now the interesting thing here is this whole record is already an object, and this object is going to store a different object that you send it. It's an object holding an object. That's why we needed to know what objects are before we attempted this. And lastly, it has a callback function. Callback function, remember, is kind of like an on event. It's something that the program triggers after it successfully completes this command here. So if we successfully add Alice to the database myTable, we'll see this console.log get triggered. And if we don't, then this won't get triggered. So this is a good way to kind of double check, did everything work out the way I expected it to. Please go through this lesson on your own. So lesson 9 is going to be due this Sunday. And it's really not difficult, very straightforward stuff, but again, gives you a lot of utility with your programming. So I thought it would be good to know about before we kind of wrap up our semester. And then we'll do a couple more things with permanent data storage next week, and we'll pretty much be done after that. So I hope you guys are doing well. Please come to our live sessions. That's all I have. Please email me any questions you have, and I hope you guys are staying safe. Take it easy.